Hello. Hello and welcome to this video. In this video, we are going to talk about a specific concept related to functions, which will help us a lot in the next video. Next video will be on closures, or however you pronounce it, closure. Now, to understand all the details of closures, what you need to understand is in JavaScript, functions are first-class objects. Typically, when you do programming in, for example, C, C++, to some extent Java, I believe, I don't know Java, so I don't really know how Java works. So in these languages, statically typed languages, functions are usually not the first-class object. Some modern functions like Rust treat functions as first-class objects and we can pass them around. The real concept comes from the functional programming languages, things like lists and schemes read to functions as first-class objects. In fact, list and scheme treat the entire code as data. So that's an entirely different paradigm. I don't know about Haskell, but I expect Haskell being a functional programming language, the function should be first-class objects in that as well. Now, what it means that a function is a first-class object. What it means is that you can treat it as if it's a plain variable. Okay, you can assign it to variables, store in the properties of objects or elements of array, pass as argument to other functions, and so on. So consider a function add xy, which returns the sum of x and y, and we assign this to a, and then we invoke as if function was named a. Now, this might seem superficial because it looks we are just renaming the function add to a, but in practice, a is a proper variable and you can assign other properties to a as well, as we will see soon. Okay? So let's see this in action. So we run this and we indeed get 16 as the output. That is the sum of 7 and 9. Okay? Now let me comment this out and we will have something else. So now we see that functions can also be assigned to object as a property. So here O is an object, square is a property, and the value of that property is a function which squares an argument. Now we can invoke this property, which is essentially a function, as if it's a function. So it is essentially a function, right? Okay, so the value of the function we invoke with argument 16, and we'll see the output is 256. There we go. So let me delete this and comment this out. Now we can do the same thing with arrays as well. So consider that we have an array A, and in the first element we have an anonymous function. So when you put the functions in an array as an element, you don't even need to name it. So it is an anonymous function, takes an argument x and returns the square of it. And A1 is 20. So now you see it is kind of awkward syntax, but you are invoking a function on 0th element and passing it A1. So the expected output should be 400, and we will indeed get 400 as the output. So that's how we can put functions at various places. Now we will look at somewhat different example. So here, okay, here we have 4 functions, the arithmetic functions add, subtract, multiply, and divide. Each of them take 2 arguments, okay, x and y. And the return value is addition, difference, product, and division. Now we have a function which is operate. It takes 3 arguments, operator, operand 1, operand 2. And return, it applies operator and passes operand 1 and operand 2. So now you see what I is. So first we take the inner values. We have operate. It will call this function. An operator would be multiply, and then it will call with 4, 5. So 4 and 5 will be multiplied. Okay. Then it will add 2 and 3. So this will give us 5 and this will give us 20. And finally we add them, so it will become 25. And let's log this console.log 5. So it should return us 25, right? And we indeed have 25. So this particular example can be further extended. So this example is now further extended here. Now we define operators as an object. We have property add, which is an anonymous function which takes 2 arguments, returns the sum. Subtract is also an anonymous function which takes 2 arguments and returns the difference. Similarly, multiply and divide. And we have another one, math.pow. Now this is operate 2. Now in the previous function, the safety was not there. We could have passed anything as the first argument and it might not have worked properly. But here we check whether the operator's object has a property called operation and which should be of type function. And if it is there, we invoke the value of that property by supplying 2 arguments. And here we say add space and world, and then we further add that to hello. Right? So it will become hello world, and we have pow. So pow receives 2 arguments, 10 and 2, and it will essentially become mass.pow or power function. So it will become 100. So we expect hello world and 100 as the output, and we indeed have that. Now, as I said in the beginning, the functions can have properties as well. Okay. So as an example, we have this function unique integer, and it takes a property counter and increases that. And then we initialize a counter property with value 0. And then we call unique integer. So we print 0 and 1 even. So 0 and 1 was printed. Now one more thing, I would say that, as we know, we cannot access the let and const values declared inside a function outside the function. So functions define a namespace. First, there is a global namespace. Then you have function namespace. So whatever is in the global namespace, that might or might not be available inside function. But whatever is inside a function, local variables to a function, those are certainly not accessible from outside world. And we will see how closures capture the outside environment. Functions can't capture outside environment, right? But closures can. And that will be the topic of the next video. And we can do various fun things with closures actually. And the examples will actually show you when I do the next video. So I hope that you have found this video useful and informative. And if you have not watched other videos on the playlist, then I would suggest that you go ahead and watch the earlier videos in the playlist. There are many things which you might have missed, and watching the videos will help you understand more about functions in or other things in JavaScript as such. So with this, I will take my leave, and I'll meet you in the next one on 4th day with closures and how closures work. So once again, thanks a lot for watching the video. I wish you all the very best in your learning, and we'll meet again in the next one. So have a nice day, and sayonara.